When a new zero-day vulnerability drops, the clock starts. You type the blast radius command, and instantly you have the entire footprint of the threat across your organization. This is the Orbit Security Blast Radius agent running in the GitLab UI. Instead of spending an afternoon hunting down vulnerable instances of Log4j or a compromised dependency, you get a prioritized brief in seconds. Usually, mapping a vulnerability across dozens or hundreds of repositories is a tedious process. It requires checking dependency files, looking up recent maintainers, and verifying pipeline coverage one project at a time. The delay stems from how we retrieve this data. Standard REST APIs are strictly project scoped. They can only return answers about the specific repository they are pointed at. With 100 repositories, that means 100 separate API calls and authentication handshakes, creating a linear traffic jam. As pings scale, manual aggregation becomes overwhelming. The system bogs down trying to stitch together a coherent picture. The alternative is a unified knowledge graph. Instead of treating an organization's software supply chain as isolated islands, everything is indexed into one continuously updated, interconnected database. Replacing project-scoped API calls with a unified knowledge graph transforms enterprise-wide impact analysis into a 30-second deterministic query. To execute that single query, the agent must first understand the shape of the data. It begins by calling the graph schema. It plots the active nodes, representing source files, repositories, and specific contributors. Between these are the precise relationship paths the AI traverses. A contributor modifies a file imports a library. Once the boundaries are mapped, the system traces the exact pathways of the vulnerable library. It checks multiple vectors simultaneously. A search signal sweeps across package managers and direct source code imports. Notice this happens globally across dozens of disconnected repositories at once. It's a single operational sweep, not a sequential loop. A developer might hard-code an import deep in an obscure utility file, skipping the standard package manager. Isolated project scans frequently miss these edge cases. Querying the entire organizational graph at once guarantees you locate the vulnerability, regardless of whether it sits in a prominent root directory or buried in a forgotten microservice. Locating the vulnerable code is only the first step. You still need to know who owns it. The graph traverses outward from each affected file, following the commit history to locate the specific engineers who modified that code within the last 90 days. It isolates the active maintainers, the people who actually understand the current architecture. Next, the system audits the organization's automated detection mechanisms. It queries the CI/CD pipeline nodes attached to the affected repositories, checking for active SAST and dependency scanning jobs. Any repository failing this check is immediately flagged. Identifying these blind spots is critical. If a repository lacks dependency scanning, it is currently vulnerable and has no mechanism to detect the next threat. A repository harboring an active exploit while simultaneously lacking automated security scanning represents a compounded failure of the organization's security posture. Standard enterprise security tools often output a flood of unprioritized alerts. Handing an engineering team an alphabetical list provides zero tactical value. They need to know exactly where to start during an active incident. To solve this, the agent applies a risk ranking heuristic, using the graph's metadata to determine the actual business impact of each hit. Repositories handling authentication or payments snap to critical priority. It factors in recency next. Repositories with active commits remain high on the triage list. Conversely, dormant repositories with 0 commits over 6 months sink to the low priority tier. Standard external scanners evaluate vulnerabilities in a vacuum. They lack the architectural context to know the difference between a billing service and a test environment. By mapping business logic onto the vulnerability data, security teams can direct immediate engineering effort toward the highest value targets first, eliminating guesswork. All of this structured graph logic populates the final blast radius report right inside the GitLab interface. Based on the specific CVE data, the report outputs the exact safe upgrade version required to patch the affected library. For those repositories flagged with missing security coverage, the agent generates a ready-to-use CI snippet. Teams can drop this into their pipeline file to instantly activate automated scanning. Reporting is only half the workflow. The agent spawns discrete GitLab issues for affected repositories, routing them to active maintainers. These tickets arrive fully populated with context, exact file locations, pipeline fix snippets, and the necessary upgrade version. The sprawling complexity of a zero-day audit collapses into a unified, actionable task list, enabling queries across the entire software development lifecycle. Treating it as a unified dataset rather than just checking isolated lines of code. Organization-wide knowledge graphs automate the most labor-intensive parts of incident response, delivering an instantly contextualized workflow to the entire engineering team.